Hi everyone, in this video we're going to continue working on graphing circles and ellipses. So we want to get back to this basic equation, x squared plus y squared equals 1, which would give us a circle with radius 1 centered at the origin. And we want to make comparisons between what we've got and this. So we're hoping to look at this and spot transformations of this original circle. I am seeing some. If we have an x minus 1, that shifts our center of our circle, our whole circle, but it shifts everything to the right 1. If I have a y plus 3, that shifts everything down 3, so I know it's going to be centered now around 1, negative 3. But I have a little bit of trouble because I have these 5s floating around that don't really look like part of this. They don't look like a transformation of this because they're not acting directly on x and y. They're acting on x squared and y squared. So that's a little strange, and also kind of an important part of this function, this relation right here is the equals 1. So if we want to look at this as a transformation of the unit circle, which is not the only way to look at it, but it's what we're practicing for now. We want to divide both sides by 45 and then see where we're at. So if I divide by 45, I'm going to get 5 over 45, which is 1/9, which turns this into an x minus 1 squared over 9 plus a y plus 3 squared over 9 equals 1. Oh, and this is a typo. It had a 15 there, but I was definitely intending to have a 9. Okay, so this is actually still not quite written in a form that I can see the transformations really easily, but I think once we catch on to how to think about this, this would be good enough for me to figure out the graph. I would just say that the divide by 9, once again, is not actually acting on the x, it's acting on the x squared. And the same here, y squared and not y is getting divided by 9. So if you want to see how it acts on the x and the y, you're actually going to have to move your parentheses. So here, I'll just use scratch paper since I didn't leave myself space for this. So we really want to think about this as x minus 1 over 3 squared. Now that 3 is in fact acting on the x value, anything that happens after the squaring is acting on something else, on x squared instead of x. Anything that happens before the squaring is actually hitting your x. And the same thing here, y plus 3 over 3. Okay, so I would say that is the most clear transformations form, but I have no problem if you get used to this and you can look at this and say, okay, but I have to move it inside the parentheses, so it's actually only a stretching by 3. That's great. You don't have to write it for me, but you do need to realize that that's what's going on. So to sketch my graph, I've already said that I've shifted it to the right 1 and down 3, so I know its center ends up at 1, negative 3. But I've also got this stretching going on, so this is actually similar to before. If I divide my x's by 3, that's horizontal stretch by 3. And if I divide my y's by 3, that's vertical stretch by 3, which means that this is still a circle. I've stretched by the same amount in both directions, but it's now a circle with radius 3. So you can draw the bigger circle and then shift it, but this is a pretty nice, symmetric, beautiful shape. So I think it's fair to just say if I know where the middle is and I know the radius is 3, then I can just go up and down 3 to get the top and bottom, and left and right 3 to get the sides. And then let's see if I can connect the dots in a way that makes this actually look like a circle. Okay, not too terrible anyways. So circle with radius 3 centered at 1, negative 3 is what I ended up with here. Okay, let's do this next one. So same thing, I have a little bit of work to do here. I'm going to say right off the bat that I have a shift left 2 and up 5. So left 2, up 1, 2, 3, 4, 5. So it's going to be centered right here. And then to figure out my stretches or compressions, the 9 and the 4 are having something to do with that, but they're not directly telling me that. I need to divide out this 36. So once again, when I divide by 36, this whole thing over 36, this whole thing over 36, and this becomes a 1. Okay, so divide everything by 36. 4 goes into 36 9 times, so this 4 will cancel out and I'll get it divided by 9 again. That's not very exciting compared to last time. Same thing. And then 9 goes into 36 4 times, so I'll get a y minus 5 squared divided by 4 equals 1. And then again, if you can see what's going on there, that's great. If you want to see the transformation part a little bit more clearly, you'd actually want to move that division inside the parentheses. So you'll have to square root it, which makes this a 3. Notice if you split it back up, you'd have x plus 2 squared over 3 squared, which is our 9. And then here, y minus 5 over 2 squared equals 1. So to get that to be inside the parentheses, you have to square root it to undo the fact that anything in the parentheses is going to get squared. So again, whichever form, this one or the very top one that you want to use is fine with me. Okay, so let's see. With this one, we've already got the center. Ooh, hopefully I don't. No, I think it'll fit. I hate myself for making this grid too small. It looks like I stretched horizontally by a factor of 3. So the far left and right hand sides will be out 3 just like last time. But I only stretched vertically by 2. So the top and bottom will only be 2 units from the middle. So this one is not circle. This one is an ellipse. Okay, so there's the second one. I have a couple more in this example, and the algebra part gets a little messier, but the actual graphing doesn't really get any messier. Again, silly me did not really leave room for the algebra, so let's see if I can sneak it in here without bleed through. Let me snake another piece of paper so that I don't ruin my page. Okay, so we've got this x squared plus 9y minus 6x plus 90y equals negative 225, which is all fine and good, except that that doesn't look anything like the form I was working on up above, where I could actually see vertical and horizontal shift, vertical and horizontal stretch, things of that sort. So we have to do a little bit of algebra work on this, and the work we end up having to do is completing the square. We'll have to do it for the x's and the y's to get that form we had up above where it was x plus or minus something squared and y plus or minus something squared. So the first thing I'm going to do is just rearrange a little bit. I'm going to put my x's together, and I'm going to put my y's together. Okay, and then it's really important when you complete the square to have a leading coefficient of 1. So the coefficient on your x squared or your y squared needs to be 1. X looks great, so I'm going to continue to keep it here. I'm going to leave a little room for the actual complete the square step. The y's, I have a 9 out in front, and dividing by 9 won't be helpful because then I'd have an x squared over 9. So the only way to separate off that 9 without messing up the x squared is to just factor it out and work within the parentheses. So we do end up dividing it out of the y squared and the y term, but we don't have to divide it out of the rest because we just leave it parked out in front. And again, we'll leave room for the complete the square step. Ooh, make sure I don't go off the page. Negative 225. Okay, so if we want to complete the square on the x's, the idea is to find the perfect constant to add on to this so that it factors into a perfect square. So the trick for this, if you don't remember, is you take this number right here. Let me snag some colors. And you cut it in half and you square it. So half of negative 6 is negative 3. Negative 3 squared is positive 9. You should always end up with a positive since your last step is squaring. We need to do the same thing for the y's, so it's kind of like we have 2 different little algebra problems going on within this. For the y's, I need to take, again, this coefficient of plain old y, positive 10, cut it in half, which gives me 5, square it, which gives me 25. Okay, so this is great. I've supposedly created these two perfect squares, and I'll factor them in just a minute to make sure that everyone sees that. But you have an equation, so you have to make sure you keep it balanced. So I need to also make sure that I add 9 to this side, and then be really, really careful on this one. I need to add not just 25, but 9 times 25. Notice if I multiplied this out, what I really added was 9 times 25. So what 4 times 25 is 100, so 225. That actually works out kind of nicely. Can you see all of it? Snuck it in there? Okay. So whatever you do to the left-hand side, you have to do to the right-hand side. Be really careful when you have that factoring that you're adding the right amount. So I'm liking this. The 225s go away. So now I have x squared minus 6x plus 9, and I can factor that, and it is a perfect square. That factors into x minus 3 times x minus 3. And for the y's, I also have a perfect square that factors into a y plus 5 times a y plus 5. And then all I have left on the right-hand side is that 9. So my very last step here is going to be to divide everything by 9, which means I'll get an x minus 3 squared over 9. The 9's cancel out completely from this, so that's kind of nice. Equals 1. I guess that could be your second to the last step instead of your very last step if you want to go ahead and do this. X minus 3 over 3 squared plus y plus 5 squared equals 1. Okay, so let's see if we can have that show up right here. This is our equation. I was really boring with all these stretching by 3. So x's are shifted to the right 3 and down 5. 1, 2, 3, 1, 2, 3, 4, 5. So this is going to be the center. I also need to stretch my x's horizontally by a factor of 3. So instead of going out 1 unit to the end of the circle, I'll go out 3 times as far. So 3 units to the left and 3 units to the right. The y's don't have any stretch at all, so I really just need to do my typical 1 to the top, 1 to the bottom. So up 1, down 1, and I get this little skinny. Looks a little bit crooked, but that guy. So you should be able to identify the center of your ellipse as well as the very top, very bottom, very far left, and very far right sides. Okay, one more on this example that I'll go ahead and do right now. Let's see. It didn't seem to bleed, so we'll go ahead and just lay this over the top. Okay, last one. Similarly, we have to do some completing the square. So if you felt somewhat comfortable with that last one, it would be great to see if you can work through, especially the algebra of this one, and then check yourself with the video to see if you got it right. Okay, so my rearranging, I'm going to, just like last time, regroup. So I have 16x squared grouped up with the negative 32x. And I have 25y squared grouped up with the negative 150y. And I'm actually going to do one other thing on this step. I'm going to go ahead and move the 159 over to the right-hand side. I don't really want to mess with that when I'm completing the square, so I'll just move it over here and let it sort out with whatever else gets added to that side. Okay, so this time both have factoring. I'm going to factor a 16 out of my x's. And leave a spot for the complete the square. I'm going to factor 25 out of my y's. 25 into 156 times. Okay, let's see again if I cannot go off the paper. Okay, so here we need to figure out what to add to x squared minus 2x to make it factor into a perfect square. So if we take the negative 2 and we cut it in half, we get negative 1. When we square it, we get positive 1. Let me make sure while I'm at it, I put my 2 over here so I don't forget. Okay, for y squared minus 6y, we need to take negative 6, cut it in half, we get negative 3, square it, we get 9. And then on the other side, we need to make sure we balance this out. So we need to add not just a 1, but a 16 times 1, so 16. And then not just a 9, but a 25 times 9. Is that what we did before? Yeah, 225. Okay, so let's see. This one, when we factor, we get an x minus 1 squared. For the y's, when we factor, we get a y minus 3 squared. And then over here, oh, I add these in my head, so I see a 159, 169, 175, 275, 375, 400. Okay, that's a fairly nice number. And then I need to divide both sides by 400. Actually write this out here. We'll do it like this. Okay, so 16 into 400, oh man, so we can cancel a 4 out of that at least. If you have a calculator handy, feel free to not do it the slow way like me. And then we can cancel another 4 out, so the 16's gone completely and we're left with the 25. Okay, so basically what that just told me was that 16 times 25 is 400. So here I'm going to be left with the 16. That happens a lot, but it's not a rule that they have to be product of each other. So make sure you really do check. Okay, so I have an x minus 1 squared over 25, a y minus 3 squared over 16 equals 1. Again, I'm completely fine if you quit here and you can see the correct stretch for each. This is what you should be thinking, even if you don't write it down, that that would become a 5. And for y's, it would become a 4. At least we don't have a stretch by 3 this time. Okay, so for this last one, I see a shift right by 1 and up 3. Right, so centered right here. And then I've stretched horizontally by a factor of 5, which means instead of going out 1, I'll go out 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 to get to the far ends of this ellipse. And then I need to go up and down 4. So 1, 2, 3, 4, 1, 2, 3, 4. Okay, so it's not stretched out, too weirdly stretched out to become a more dramatic looking ellipse. It's close to being a circle, but not quite. It's a little bit wider than it is tall. Okay, so there is a rough sketch of that one. Hopefully that helped. Thanks for watching.